Hello, welcome back. We are still on the verge of covering 20 past UTME questions on this 11 most repeated topic. In the last video, we were able to touch one more on waves and also on light, right? Hope you can still remember. In this video, we're still going to continue where we stopped on the last video, so touching one or more of the 11 most repeated topic in physics UTME. If you are ready, I'm also ready. So let's jump right in. Question number 10. Which of the circuits illustrated below will give a total resistance of 1 ohm? This is taken from Japan's question 1979. Okay, so one clue to solve this particular question is just to know what happens when resistors are connected in series and what happens when resistors are connected in parallel, right? For that case, when resistors are connected in series, the total equivalent resistance should be greater than their individual resistances. What do I mean? If you look at this option A, all these are connected in series, so 2, 3, and 6 ohm. That means that the equivalent resistance of this particular option A should be greater than 2 or 3 or 6 ohm. And reverse is the case for parallel combination. The equivalent resistance for parallel combination is that equal or less than their individual resistances. Okay? Having known this, we already know also that for resistor in series, their equivalent resistance for resistor in series is equal to R1 plus R2 plus R3 up to Rn, right? And for resistor in parallel, you have that 1 over equivalent resistance 1 over R1 plus 1 over R2 plus 1 over R3 up to 1 over Rn, right? Having known this, you can agree with you that option A should be out of the option already, because 2 plus 3 plus 6 cannot give us 1. Only 2 alone is greater than 1 ohm, right? And also option D should be out of the option, right? Because this is 2 ohm resistor connected in series, like in series with this parallel combination, right? So 2 plus whatever you get is also greater than 1. So option D also should be out of the option, right? So we're only left with option B and C. Okay, let's just take the combination of B. Have that 1 over, since it's connected in parallel, 1 over R equivalent to give us 1 over 2 plus 1 over 3, and this will give us 5 over 6, so that R equivalent should give us 6 over 5. This will give us 1.2, which is greater than 1, right? So option B is also up. So the correct option should be option C, right? Because 1 over R equivalent was 1 over 2 plus 1 over 3 plus 1 over 6. That should give us 6 over 6. So 1 over R equivalent is equal to 1. So R equivalent is also equal to 1. Just to the point, right? So your knowledge of this and what happens when resistors are connected in series or in parallel will give you an edge in solving this particular question, because looking at the options already eliminates A and D direct, because this one will give us the total equivalent resistance greater than 1, because 2 alone is greater than 1, and 2 plus 3 plus 6 is far greater than 1, right? This is 2 plus the parallel combination of this. The parallel combination of this, I know it should be less than 1, but 2 plus it should also be greater than 1. So this should be out of the option already. Then you are left with 2 options. Just free option to work with, right? Let's move to the next question. So if the charge of electricity per kilowatt hour is 4 naira, what is the cost of operating an electrical appliance rated 250 volts 2 ampere for 6 hours? This is taken from Japan's question 2021, right? Remember that power is equal to the current multiplied by the voltage, right? We are given a 250 volts and 2 ampere, which is the current, right? So the power is 250 multiplied by 2 to give us 500 watts, right? But if you look at this, the charge of electricity is measured in kilowatt hour, right? So we have to convert this to kilowatt. Okay, so 500 watts to kilowatt is 500 divided by 1000. So the power is equal to 0.5 kilowatts. That's being the case, but being asked that we told that the electrical appliance is being operated for 6 hours, right? So be operated by 6 hours. Multiply this by the 6 hours, you now get 3 kilowatt hour. Okay, but we are told that 1 kilowatt hour costs 4 naira. When I'm being asked what is now the cost of operating this, so if 1 kilowatt hour is equal to 4 naira, then 3 kilowatt hour will cost what? Okay, 3 kilowatt hour will then cost 12 naira, right? So 3 kilowatt hour costs 12 naira, and this is option D. That's it to the point. So the first thing you have to do is just get your power, which is 250 multiplied by the current, which gives 500. Convert that power into kilowatt, divided by 1000, then multiply it by the number of hours given. Then you don't use proportion to check that if 1 kilowatt hour is costing 1 so naira, then the kilowatt hour that you got should cost how much, right? That's straight to the point. Okay, move on to the next question. 4 grams of a radioactive material of half-life 10 days is spilled on a laboratory floor. How long will it take to disintegrate 3.5 grams of the material? This is taken from JAMB Passport 1991. They are given option A to D to choose from, right? So the initial mass of the radioactive material is 4 grams, right? A half-life of 10 days is given to us. They say how long will it take to disintegrate 3.5 grams of the material? So if it disintegrate 3.5 grams of that material, the amount of material remaining should give us 4 grams minus 3.5 grams. This is 0.5 grams, right? If that be the case, that means we are being asked how long will it now take for this material to remain 0.5 grams, right? Because from the relation, you can just, many people prefer using the relation, but I do not advise because it's very, very long. But we have that the amount remaining should give us the initial amount 1/2 raised to power t divided by the t half, which is the half-life. Okay, this is one relation. The amount remaining is 0.5, right? So 0.5, the initial amount is 4 into 1/2 raised to power, the t is what we are looking for. The half-life given is 10 days, right? So 0.5 divided by 4 will give us 1/8. Will give us 1/2 into t/10. So to solve this, we have to apply logarithm, right? So many people don't know how to use logarithm, but I'll just show it here. Okay, so we now have 1/8 give us 8 raised to power minus 1. 1/2 give us 2 raised to power minus 1. Then into t 1/10. This will give us 8 raised to power minus 1. Give us 2. Then raised to power minus t/10. Right? If that is the case, then apply logarithm. Log 10 of 8 raised to power minus 1 to give us logarithm of base 10 raised to power 2 minus t/10. Okay, using the law of logarithm, this will now give us minus log 10 raised to power 8 should give us minus t/10 log 10 to the power 2. Right? So negative can cancel negative. Then logarithm of 10, 8 is 2 raised to power 3, right? Should give us t/10 logarithm of base 10 raised to power 2. Right? Using the law of logarithm, this will give us 3 log 10 2 should give us t/10 logarithm of base 10 raised to power 2. So this can go. So now I'm left that t3 is equal to t/10, then t is equal to 30 days. Okay, I see that the correct option is option C, but this method is actually long, right? For you to solve all this logarithm, and many of us I don't know how to use logarithm or the law of logarithm, right? So I'll just show you how to just do it. These are right in a simplified manner. We are given that the mass initially is 4 grams. Now calculate to calculate the time taken for it to disintegrate 3.5 grams, so the amount remaining is 0.5, right? If you know what half-life is time taken for half of the maturity, okay, right? So, and the half-life given to us is 10 days. So, for the first 10 days, half of the 4 grams should remain, right? That is 2 grams should remain after 10 days. Because that what you are looking for is the time taken for it to remain 0.5 gram, right? So this is where you are looking at. So after another 10 days, which is now 20 days, half of 2 should remain, which is 1 gram. After 30 days now, half of 1 gram should remain, which is 0.5 gram. So for it to remain 0.5 gram, you should have spent 3 half-life, which is 30 days. This is straight to the point. So doing this is far easier than doing this, right? Because solving using logarithm is very long, but your knowledge of what half-life is, how to navigate it, is easy and straight to the point. That's why the correct option is still option C, 30 days. Okay. So in this question that I have solved, we're able to touch the current electricity and introductory modern physics. You see how simplified I made the solution, right? To get more simple explanation of past questions on this 11 most repeated topic and other various topics in physics UTME exam, then you need to get the iClass Simplified UTME video series. Let's Part Tutors give step-by-step explanation to over 600 plus past UTME past questions for each subject. These questions and their solutions are arranged topic by topic according to the UTME level. This is one study material you must get if you wish to score very high in UTME exam. So you can call or chat the number on the screen to get yours now.